record in another platform. Shall we start?
Yes,
So you can unmute yourself and also reply in chat whenever necessary. All right. So I'm expecting you all to be more interactive. Yes. So people who have joined fresh this time, you can share which course you're studying or which college. That will help us get an idea of what audience we are dealing with. Do let me know if you can see my screen. Is it visible? Am I audible?
yes, you are audible.
I can't hear you. Okay, I think today is just a bad day for technology. Okay. All right, we'll start. Okay, somebody sending messages. Okay. Oh, Sumit. Hello, Sumit. And welcome back, Sriram. I don't think anybody else from previous session has joined. We have Dr. N. Saravanan joining us. All right, then. So let's start. So we are getting into the second week of Principles of Downstream Techniques in Bioprocess. This will be the second live interaction session. I am Lavanya N, a PhD scholar from IIT Madras. So I'll be handling these live sessions for the next 10 weeks or throughout this particular course. So I welcome you all to the session. So the topics for this week are costing, physical and chemical principles in downstream, problems in mass balance flow sheet, and cell breakage. So let's start with the first question. I'll give you 2 minutes to take in the question and give your answers. So I expect that you will be sending in the answers through the chat box. So let me read out the question for you. The cost of setting up a plant in Cochin is 2,500 crores, and the annual return is 100 crores. And the cost of setting up a plant in Delhi is 3,500 crores, and the annual return is 150 crores. Where should I invest? Is it A. Cochin, B. Delhi, C. No difference, or D. Cannot say? you can type in just the option. And I hope everybody has gone through the lectures. If not, you can let me know. Okay, shall we look into the answer? Is anybody facing a difficulty here? That's great, Sumit. Thank you for answering. So, does all of us agree with Sumit Roy? The cost of setting up a plant in Cochin is 25,000 crores and the annual return is 100 crores. So, if we thought of a payback or how long we'll be able to get the profits, and when you start a company, you're not going to do it for 2 years or 3 years and give up, right? You're going to think long term. So, although the cost of setting up a plant in Delhi is higher, yeah. So, although the cost of setting up a plant in Delhi is higher, the annual return is also correspondingly high with Delhi, right? Suppose if I were to divide 2,500 by 100, what would that give me? 25, right? And if I were to subtract 3,500 by 150, that'll be 23.33. So whatever you have invested initially, you will be able to recover it in 25 years with respect to Cochin, and with respect to Delhi, you will be recovering it in just 23.3 years, or let's say 23.5 years. And over and above, you are going to be drawing greater profits each year than Cochin. So you will go with Delhi. Are we all agreeing on this? Okay, due to lack of response, I'm assuming that we are all on the same page. Let's move on to the next question. If cost of 100-liter vessel is 15 lakhs, what will be the cost of a 250-liter vessel? Sure, Sriram. So in the first question, we are starting with two scenarios. You have okay, you have Cochin on one end and Delhi on the other. So the initial investment to set up a plant in Kochi is 2,500 crores, and that, can you please write the question in chat? Which question, George? First or second? Second, sure. So that George can, work on this while we solve. I'm sorry. How do I go back to select? George, can you note this down? I'm unable to select right now. Yeah, I guess now I can. Okay, back to the first question. So, the initial investment is 2,500 crores in Cochin, and for Delhi, you have 3,500 crores. So, Delhi is greater investment than Cochin. So, you're going to chip in 1,000 more crores here. But later, each year, the income is 100 crores in case of Cochin and 150 crores in case of Delhi. I mean, you can visibly see that the profits are higher in Delhi than in Cochin. So here, Delhi is favorable, whereas the initial investment is favorable with Cochin. So where do you go? Which one do you decide? This a 50 crores seems very small, whereas 100 crores seems big here. So that is why I suggest that you divide the initial investment by the profit you make annually. So what do? 2,500 divided by 100, and both are in crores. Don't remember the units, and so we slash it and we end up at 25 years, and this is 100 crores per year, so that's why you get it in the numerator. And again, here you have the initial investment of 3,500 crores and divided by 150 crores that you get as profit annually. So that gives you 23.33 years. So you see that you are able to take back your investment or earn whatever you have invested in 23.3 years if you set up the plant in Delhi, whereas it is going to get 25 years if you set up the plant in Kochi. And from 26th year onwards, you are going to get only 100 crores per year as profits. And in Delhi, from 24th year or 25th year, you're going to get 150 crores per year. And we are doing all this calculation based on assuming that the cost is going to be the same or the profits are going to be the same, and each year you're going to be in the ballpark figure, if not the exact value, at least close to it. So if you consider this, then Delhi is a wiser option to invest than Cochin, right? So let's move on to the next question. If the cost of 100-liter vessel is 15 lakhs, what will be the cost of a 250-liter vessel? I see that a lot of people have answered 37 lakh 500. So if you have done this normal equation of what is 250 lakhs, I think most of the people have done this. I hope everybody has taken the time to work this out. So you would have done 250 into 15 divided by 100, right? But does this mean that we have either forgotten or not listened to the lectures? Sorry, that's a mistake in the decimals. So if you do it this way, you will get 3 lakh 37 lakh 50,000 as the amount for 250 liters. But did you all take a moment to remember what was there in the lecture? So when you're going to do a scale up, it need not always be a proportional case as in this what you just did, right? So sometimes the cost of, let's say, vessel 1 divided by cost of vessel 2 equal to size of vessel 1 divided by size of vessel 2 whole power. Okay, Usha has also answered. George, Sriram, Shrey Singh, Sumit Roy, yeah, and Hrishikesh. So do you remember something that was raised to the exponent of about 0.5 to zero point 0.7, right? And typically, Dr. Doble said that you will have zero point 0.6 rule. This was in the first lecture, I guess, costing week 2 first lecture. And so we will be using this particular rule for calculating what is the amount, because when you scale up it's not exactly the same thing. You would have noticed this with let's say your favorite let's say you're buying Horlicks or Boost or some health drink, or you're buying Rin liquid, any of the groceries. So 100 ml might cost, let's say, 56 rupees. 250 ml packet might not cost whatever that should be, 56 into 250 divided by 100. So this says 140 here, but most of the time you see it is 110 or 109 or 112, something like that, right? You get a discount when you're going up to the higher volumes. This is mostly because people want to send it sell more of their produce, and when you buy a larger portion you tend to get a better discount. Similarly, here it is not about selling a produce, but rather when you are scaling up from one quantity to a bigger quantity, the fabrication may not be strictly proportionate, right? So we generally go with zero point 0.6, zero point 0.5 if it is easier to scale up, zero point 0.7 if it is a little tougher to scale up, right? The value might vary, but if you were to follow this particular lecture where you scale up with the exponent zero point 0.6, now do you want to work this out and let me know what the answer is? Let me fill in the knowns for you so that it's easy. So I'm going to take the next page because I have one more page. So size 1 by size 2. I'm going to flip it because I like to have my unknown in the numerator. So I'm going to write 250 liters divided by 100 liters whole power zero point 0.6 is equal to uh, new cost divided by 15 lakhs. So what is this? 250 divided by 100 whole power zero point 0.6, that is 1.733. It was 28, so I'm approximating it to 3 decimals, and we are going to multiply the old cost here. I'm taking it to the numerator. There is the new cost, which is equal to 25 lakhs 99,293.162. I'm going to approximate this to 1.733. Actually, I had done it with the decimal, so if you were to do it without the decimal, you have, with this approximation, you will get this as your value. Did everybody check? Is it clear for all? Should I repeat? Because I think about 6 of you have answered the same thing, which is 37 lakhs. So 25 lakhs is lesser than 37 lakhs 50,000, right? It's almost equal to 26 lakhs if you think about it. But still, you have about 11 lakhs, 11.5 lakh difference. Was that clear? So you have a similar problem in week 2 assignment. So you can use the strategy of using the zero point 0.6 rule and arriving at the answer. Clear? Shall I proceed to the next question? If you're uncomfortable, you should really stop me. Okay. Question 3. Streptomycin is a high value, low volume product, low value, high volume product, high value, high volume product, or D. Low value, high volume product. Okay, Sriram. So, this is the formula. Do you want to copy this down? You can also take this from the lecture material. So, let's look into question number 3. So, streptomycin is an antibiotic. So, what type of product is it? A, B, C, or D? Shall we look into the answer? Sure. Streptomycin is a high value, low volume. So, in case you're not aware of what this means, so sometimes you have, let's say, um, how can I simplify this for you? Uh, how would you, I mean, what do you like? All the junk food is costlier, whereas some other stuff which is a little more healthier is generally cheaper, right? You cannot equate the same thing here. Certain things are of high volume. I mean, you will produce it in large volumes and the price will still be low. For example, let's take rubber bands. It is produced in high quantities, right? Or let's take plastic covers. You make high quantities of plastic bags each year, and therefore the cost is very low. When plastic was introduced for the first time, it was very expensive. Only rich people will have plastic bags, and then when the production was increased, when a lot of people are producing and at large scales, the price comes down. So the value is reduced, and the production, the batch produce each year or each month is high. So the volume increases and the value decreases. That does not mean that whenever you produce something in higher quantities, the value should always decrease. It will decrease, but you need not always associate high value to only produces products that are produced in low volume. But generally, that is the case because you get it. The difficulty of synthesizing something can also uh, lead to a high value, or the purity that you need will also lead to a high value. But if you're buying some cosmetics or something, the volume will be very low. That if you take different brands, you will have very little volume costing very much, right? So the value of a cosmetic is much greater than a value of other departmental or toiletry products that you have, right? So similarly, streptomycin being an antibiotic, it is biologically, I mean, most antibiotics are synthesized, all these biopharmaceuticals or biologicals that are synthesized with microorganisms are going to be tougher to manufacture than what would be a casting, drilling, mechanically produced, or something that is chemically synthesized. right? Even chemical synthesis, certain compounds, you will have so many isomers together. The process of extracting it or the purifying downstream processes will be very costly. So these, like how I explained, streptomycin here is a high value, low volume product, whereas ethanol, butanol, or some other compounds that you get in large quantities is a low value, high volume product. You're going to make a batch produce, I mean, continuous. You can have a continuous stir tank reactor if you're already aware of these models, to continuously synthesize these chemicals and have it like citric acid, HFCS, and things like that. Okay. Also, you're not going to consume kgs of antibiotics. It's going to be taken in mgs, right? And the purity is supposed to be higher. Let's move on to the fourth question. Extraction is based on A, partition coefficient, B, molecular weight, C, non-bonded interaction, and D, solubility. What is it based on? I would request you all to hurry up because we have more problems to solve. And we have a total of 10 questions here. Can't you see the options? Option A is partition coefficient, B is molecular weight, C is non-bonded interaction, and D is solubility. Which of these phenomena is extraction based on? Or which is the criterion that determines or you will look for when you're trying to extract something? Is it weight based? Does molecular weight or size have anything to do with this? Is it partition coefficient? Is it non-bonded interaction? Is it solubility? So, what is partition coefficient? I hope you know the other three. So, partition coefficient is when you have two liquids in contact with each other, need not also be in contact with each other, but partition coefficient tells you how much a particular solute likes a solvent, right? How much a solute is able to dissolve into the solvent. A higher partition coefficient means it likes the solvent more. A lower partition coefficient means it is not so it is not so soluble or miscible with that soluble rather in that solvent, right? Higher means it will transfer more, lower not so much. So when two solvents are in contact, if a particular solute is in A and you have another solvent B, and they are mixing with each other, not strictly in a straight line, they are just visible mixing with each other. How would this particular solute go into B or rather stay in A? There will be multiple solutes. So if I were to color this, I can have one solute which I have shown with yellow and another solute in brown. It's a bad choice of color. Let's say I have another one with green, and I want to extract the one that I am giving now in red. So what is the most ideal situation when I get more of red here and less of the other impurities, right? I probably just get one or two and one or two molecules of the next solute. So if The red molecules or the solute that is I'm depicting with red color has a higher partition coefficient. It will move on to the other solvent that you have. And since extraction is a liquid-liquid separation process, generally, where you're trying to extract, you can also have solids having the particular product of interest, and you can pass a liquid over it, and the solute can move into the liquid. Generally, when we're talking about two solute solvents that are in contact with each other, and based on partition coefficient, it is going to move from one solvent to the other. So you're extracting it. Correct. It is not based on molecular weight. You would rather do gel electrophoresis or size exclusion chromatography that is dependent on molecular weight, or mass spectrometer, not extraction. And those are analytical rather than, mass spectrometer would be an analytical technique rather than a downstream technique. And non-coordinated interaction will be there in, say, absorption. I'm sorry, adsorption, right? And solubility would be the case when you're trying to do diffusion or absorption. Solubility will also play a role along with reaction, right? So this will be gel filtration chromatography or size exclusion chromatography, both are the same. Partition coefficient is the right answer that determines the extraction. So you need to have a good affinity for the solvent you are extracting with. So the partition coefficient should be high. And also there should be a good difference between the impurities and that of the product of interest. I'll change the color because I don't think it will be visible. Right? So is everybody clear? So question 4 answer is A. Partition coefficient. Let's move on to question 5. Gas chromatography can be used for separating what? A. Enzymes. B. Proteins. C. Alcohols. And D. Peptides. So look into all 4 options. And I want all of you to participate in this rather than just a few of the participants, those who have joined to respond in chat. And it'll just make it interesting for both of us, because there's nothing wrong in answering, typing in the wrong answer. So this is not going to be graded, it's just between you and me, right? Thank you, Sumit. So shall we discuss? Sumit has answered right. So if you see here, proteins are mostly heat labile. Peptides, proteins, enzymes, all are proteinaceous, right? You can easily see that there's an odd one out here. And alcohols are more resistant to temperature. And gas chromatography obviously is going to uh, act at higher temperatures. So enzymes, proteins, and peptides cannot be processed through gas chromatography. We would rather go with steps of chromatography, either affinity or size exclusion, right? And enzymes are going to be even more sensitive, even at room temperatures, and they need particular conditions to stay active. So the answer is alcohols. The answer for fourth question is A, partition coefficient. Okay. So let's move on to sixth question. 2 liters of water is used to recover 30 grams of a plant metabolite. A fermenter broth contains 1 kg of a metabolite. How much water is needed to recover 95% of this antibiotic? So I will give you all 1 minute or 2 minutes, let's say, to think about this question, work out an answer. Or if you think you don't know, you have to let me know before so that I can start explaining rather than waiting for you to work on it. I'll just write down what's given here. So don't mind me. You just carry on with working it out on your own. Somebody speaking, I'm unable to hear. Can you type in the answer? I mean, whatever you're trying to speak. I'm having very poor reception today. Is it tough for you all to see the screen? Because once again, I see somebody wants me to post a question in the chat box. So, 2 liters of water. Oh, for how long has it not been visible? Just now, or
From the beginning.
oh my god, you should have told me this. Okay, so my meet screen is visible, but the PDF is not visible. Is that right?
Yes.
PDF was not. Oh god,
Yes, sir.
you should really tell all this, man. Okay, so would you mind if I cut this call and start again? I want you all to rejoin. Is that possible?
Okay. Okay, ma'am.
Like all 10 of you.
Okay, ma'am.
Okay, so is it visible now?
Yes.
One second. Okay, for all future weeks, uh, 1 second. I want you to tell me if you can't see such things, okay? So this run, I'm trying to do the screen recording as well as teach. So, I mean, if I have the Google Meet on here, my face is not visible there, or the resolution of the video is bad when I upload it on YouTube. So I wanted to have a bigger screen here and also show my face, which was hard because I cannot use the webcam in both places. So I'm going to not worry about the screen recording and focus on the live session for now. So are you all able to see clearly the PDF? And anytime you stop seeing this, I want somebody to ping me. Okay, use the chat box to tell me that something's not working. All right. So let me do a quick recap of everything. So I've been dividing here and showing you. When Sriram asked, I had to do again, but I guess none of that was visible. So we are clear with question one, right? Here you have a bigger increase in case of Delhi with respect to annual returns, whereas the initial investment is higher with Cochin, but still you divide this up and look at it and go with Delhi, right? So question two was okay. That's why you had asked for the formula. My bad, sorry. So I had written it here and then I worked it out. You can, of course, I'll be sharing this PDF with you. You can take a minute to think about things. So then I had all these colors here. At least then you could have told me, guys. It's all right. So the answer was partition coefficient. Fifth was alcohols. So we are moving into sixth question here. Take a minute. So if you 2 liters of water is used to recover 30 grams of plant metabolite. A fermentation broth contains 1 kg of the metabolite. So this is what we are interested in. So 1 kg is 1000 grams. But think about how much percentage of this is actually going to be extracted. And how much water are you going to need in the end? That's the question. Any answers? Or do you want me to start explaining?
1 minute, man.
Take. That's right, Rishikesh. We'll wait for another half a minute for others to drop in their answers and then we'll look into it. Okay, shall we move on? So you're having 1 kg of metabolite in a fermentation broth. Great, George. Thanks. How much water is needed to recover 95% of this antibiotic? So you're going to recover only 95% of 1 kg. So what is that? 0.95. Is this color visible? We'll take this. Yes. So 0.95 into 1000 grams, right? What does that give you? 950 grams. So this is your target value, or this is the amount of metabolite you are essentially going to recover. So for 30 grams you need 2 liters. For 950 grams, how much do you need? That is 950 into 2 divided by 30 in liters. So there goes these two. So 9 2s are 18. So 190 divided by 3. Am I right? So 6 3s are 18. Another 6 3s are, I mean, 3 3s are 9. So that will be 63.33 liters. Right? Does anybody want to object or have a different answer or think I should explain again? Clear?
Yes.
Okay. So let's move on to question 7. This is useless. An extractor can recover 85% of the desired protein with 1000 liter of ethyl acetate. If I add one more extractor and another 1000 liter of ethyl acetate, what will be the overall recovery of the protein? As usual, take 2 to 3 minutes to go over this problem. Meanwhile, I'm going to be drawing the schematic of this for a better understanding. You can just ignore me and go on with your answering. Sumit, do you want to rethink your answer? Okay. Okay. Thank you, George and Sumit, for answering. And Shrey, you are right in a sense, but let's see where we are making our mistakes, right? So, according to you, you're saying I'm having 85% efficiency here and 85% efficiency here also, right? So, you're saying same, correct? You can also unmute and speak to me. Now, my audio, video, everything is fine. Okay. But the problem is, you're right, 1000 liters is going to have the same efficiency each time. Correct. So an extractor can recover 85% of the desired protein. So I don't know what the exact quantity is, but let's take these as the quantities, the arrows that are coming down as the ones that I'm actually going to use. So what does that mean? 0.85% of P I've extracted successfully from extractor 1 E1. Okay, and the waste from this, what is that? Out of 100%, that's going to be 15%, right? 0.15 p is going to the second stream. Now it is very important for you to understand that I'm not going to put this stream there. 85% of protein p I've already extracted from extractor 1. I'm going to directly take this to further processing, or I'm going to use this. Correct. Whatever waste I'm getting out of this, so I was able to take only 85% of my desired product. 15% is going waste. I don't want it to go waste, so I'm going to put another extractor there to extract whatever is possible from that 15%. Now this 15% is the 100% for this particular stream. This is the entry, right? And it is going to extract only 85% of that 15%. You understand? So the output I'm going to get from this is 0.85 into 0.15 p. And what is the output? 15% of this 0.15 into 0.15 p. Are we on the same page here? Do you understand? Shall I repeat? So you're getting two outputs, one from first extractor and another from second extractor, and this put together is going to give you the final efficiency. Are we clear? Do you want me to explain again? Did somebody say you want it again? I can't hear. I'm sorry. Just use the chat box, or shall I proceed? Was clear. Great, George. So if you calculate this, what is it going to be? What is point? I'm going to use my calculator. 0.85 into 0.15. That's 0.1275 P from second extractor. And from first extractor, we know that it is 0.85. So add both. You're getting 0.9775 P as the total recovery. So that is what the answer then. 97.75% is the recovery of the protein. Was that clear? Shall we proceed? Okay, I'll take that as a yes. Question number 8. In problem 7, if I add only 500 liters of acetone in the second extractor, what will be the overall recovery? And most importantly, assume linear relationship between extraction, efficiency, and quantity of acetone added. What does that mean? If you have 1000 liters of acetone giving you an extraction efficiency of 85, efficiency is going to be the same, but quantity, I mean, how much do you get from it? 500 liters is going to be able to take only half of that. 500 will be how much? Makes sense, right? If you're going to use 100 liters, if you're able to extract 85 grams of it, 500 will be half. If I'm going to use 2000, it's going to be 170, right? So employ that and use the same diagram. I'll see if I'm able to copy and paste that part here, and you can. Okay, I'm unable to do that. It's possible with PPT though, I guess. No, not here. No problem, I can draw it while you work on the question. So you're having 1,000 liters here. If I had only 500 liters of acetone in the second extractor, what will be the overall recovery? So you already know that here you have 0.85 of P and you have 0.15 of P here, which is the input into the second extractor. And what are you going to get? You can think this as same 0.85 into 0.15p into 500 by 1000. This is one way of doing this, where you have 1 by 2 here, or you can also do it as let's say 0.425 into 0.15p, however you want to do this. And here instead of 0.15 into 0.15p, you will have into 500 by 1000. So that's again changing this as 0.075. That's right. Yeah. So essentially at the end of the day, you're just having 0.075 into 0.15p, and here you're having 0.425 into 0.15p. That's clear, right? So do you want to work out the answer and tell me? So 375 I'm going to approximate as 38 or 4. So you what will the overall recovery? Let me take the next page if everybody is okay with this. Is 91.38 or 4 percentage. Yes. Okay. Clear? It's very similar to question 7. Okay, let's look into question 9. When cells are broken in homogenizer, protein A followed by protein B, and finally C get released. If the release process follows a first order kinetics, then the release constant for B is less than C, B is greater than C, B is equal to C, and A is equal to C. So remember that C is equal to C naught into 1 minus E power minus KT. Right? So it follows first order kinetics. This was the formula. And we are talking about release constant K here. So think about this particular thing. So they're saying that A comes first, followed by B, followed by C. Comes as in it is not going to literally come out in a, how do you say, train like fashion, one after the other. The thing is, in a homogenizer, when you're sending in the input, and after each cycle of homogenization, if you were to analyze the content or concentration of each of these entities or species in that liquid, first A's concentration peaks, then B gets released, and finally C is released. So if your focus is on B, you would start collecting the fractions after A, and you will not homogenize too much that C starts getting released. Correct? So you will have to wait for the A to release, and then B starts coming out. Of course, you will have both A and B, and you will have to find a method to discard A or remove A. And you will not homogenize so much that C starts coming out. So you will work on the time to prevent that. Suppose your desired product is A, you will do only so many cycles so that you are able to extract just A, and prevent B and C from coming out or getting released. So we are talking about K here. So the release constant for A, B, and C. So how is Ka, Kb, and Kc related? Remember that C naught is going to be greater than C. So this is going to give you an improper fraction, right? So that will be something in decimal. Let's say we do a ln of 0.5. So logarithmic of anything, let's you can substitute 80% or 50% here. If this is 0.5 of C naught or 0.8 of C naught, I'm just doing this for you to get the logic of what is happening here based on the equation. And you will always find that this ln answer will be negative, so that will cancel with the negative sign here. Okay, so finally what is it? Let me scroll a little bit so that I can use the space in the next slide also. So Kt is equal to negative ln of 1 minus C by C naught. This is going to give you a positive sign at the end. And you know that time is going to be in the denominator now. So the one that comes out, A followed by B followed by C. So the time for A is going to be least. So TA is lesser than TB is lesser than TC. Right? So when the denominator is low, the numerator is going to be big. What does that mean? Ka is going to be greater than Kb is going to be greater than Kc. It makes sense. When the release constant is high, the time taken is low. So it gets released very easily. It is going to get released first. Therefore, the time is small, which means that particular molecule is going to come out first. Does this make sense for everybody? So the right answer here is Kb is greater than Kc. B is greater than C. I have not highlighted here by mistake. So option is B. Are we all clear? Do you want me to repeat? Thank you, George. So let's move on to question 10. I hope it's clear for everybody. Right? In a cell disruptor, the rate of product released is a function of pressure power 1 by 3. So rate is related, I'm using this symbol here, is a function of pressure power 1 by 3. I hope this is visible here, or I can move it a little bit. If the rate has to be doubled, what should be the increase in pressure? By how many times? So I'll give you 1 minute to think about this. It's a very simple relation. Let's use it as R related to P power 1 by 3. And I want 2R here. What should I do to P so that I get 2R here? I want twice the rate. You cannot use it like a equal to relation here. Just think about what should be done. Okay, think about this, George. So pressure, a cube root of pressure is taken, and it's related to rate. So if rate has to be doubled, uh, 1.25 is very smaller number for you to be able to. Okay, let's give a half a minute for others to think about this, and we'll see what can be done. Since we are taking two different scenarios, you can now equate it, because the constants, we are talking about proportionality here, so there will be one constant. But when you're talking about two quantities, then those constants will cancel out, so therefore you can bring a equality symbol here. Is that okay? Now I want R2 is equal to 2 into R1. So R1 by R2 is equal to P1 by, oh I'm sorry, R1 by 2 R1 is equal to P1 by P2 whole power 1 by 3. Right? I want to take this out. So let me do cube for both sides. So R1 by, I can cancel this out, right? So 1 by 2 whole cube, maybe I should put an arrow like this, is equal to P1 by P2. And now I'm not going to have any 1 by 3 because cube by cube becomes 1. Right? Okay. Which makes P2 is equal to P1. So this goes here and this comes down, divided by zero point 0.5 whole power 3. Am I right? Am I making any mistakes? 0.5 cube, that comes down here. Yeah, this goes. So what is 0.5 cube? 0.125. 1 divided by answer is 8. So P2 is equal to P1 divided by 125 is equal to 8 P1. So how much should I increase? By 8 times. Is it clear, George? Is it clear for everybody? I can repeat this if you want. So R. Okay, thanks, George. Is it clear? Do you want me to repeat others? Proportional to? Clear? If we are all on the same page, we can close the discussion. Is there anything else that you want to ask me? Some question, doubt? If there's nothing else, we can close the discussion and meet next week. I expect all of you to be present for the next week's live session. Of course, there's no penalty whether you answer wrong or if you join or don't join or speak or not. Yes, sure, Shriram. I can also work it out. I mean, that's a little haphazard there. If you want me to work this out again for you, I can do. So R1 by R2 is equal to P1 by P2 whole power 1 by 3. So R2 is going to be twice of R1. So R1 by 2 R1 is equal to P1 by P2 whole power 1 by 3. I cancel these out. So I have 0.5 whole cube is equal to P1 by P2. So P2 is equal to P1 by 0.125 is equal to 8 P1. So 8 times is your answer. Clear? I think you should be able to answer all the questions in the current week's quiz without any difficulty. If you face something, you can always let me know in the next session, or you can also post it in the Ask a Question portal. So if everybody is okay with it, we'll close the current session. Thank you all for joining. Okay then. Bye. Take care. See you next week.
Bye, ma'am.